In the previous video, you guys saw the basic fundamental units, or we can just call it as basic units, correct? You guys saw the table, the length, mass, time, temperature, all these things, correct? Now in this video, you guys are going to see the first basic or the first fundamental unit, which is length. Now everything has length, correct? And you are going to measure every length. You say, my school or my college is so many kilometers from my home. Very simple thing. Kilometer length, which is the distance. Correct? Now, everything has length. You can take from the shortest of the atom to the biggest of the galaxy. Everything and anything you see, it has length. Okay? Now, how do we measure length? There are two methods. Alright, now the first method is to measure very long distance. When I say long distance, I'm talking about the astronomical scale. Okay, not in terms of few kilometers. I'm talking about an astronomical, like distance between sun and the other star, or distance between one end of the galaxy to another end of the galaxy. Okay, guys, it's not practical to use kilometer. You guys know that because it is so big. It is so big. You can't measure the distance from Earth to Sun in terms of kilometer. We have to use different methods, correct? Now, here, to measure longer distances, like when I say longer, just like I told, astronomical distances, we use a method called as parallax method. Okay? Now, parallax method here, what you are going to do is, take a look at this particular image. Now what you have is that sun is there, correct? And earth is on one end. You can take right or left, any one of it. If you are going to take the left one, see what you are measuring. And the same star, you are going to come towards the right side and you are going to measure. See the angle what you get? We make use of trigonometry and you are going to figure out the distance with the help of that angle. Okay, now this is what we call as parallax method. Now to give you in a very simple perspective what is parallax method, you guys can do on your own. Guys, very simple. First what you do, you extend your arm. Okay, now keep the thumb finger upward position. Okay, something like this, and extend your arm. Close left eye and see the position of the thumb. Okay, and keeping the position of the thumb in the same place, now close your right eye. If you look from your left eye and from your right eye, there is a small change in the position of the thumb, correct? Now this method is what we call as parallax method. Now we use the same thing in calculating the astronomical distances. Okay, now this is for very long distance. Now when it comes to very short distance, very short in the sense, what if I want to calculate intermolecular distance, interatomic distance? Okay, in such cases we have different methods. When I say different methods, we have something, we can use lasers to calculate the distance. Okay, or we can use different types of lights, maybe like red light, blue light, green, different types of lights. We can calculate the distance between two molecules, two atoms, something like this. Alright, now for general cases we have kilometer. Very simple. We can use, for certain distances we can use measurement tape, correct? So measuring tape is very helpful. And for other certain distances we can use the speedometer and calculate, correct? Like so many, you are going at this particular speed for this much of time. Distance you can calculate, correct? So there are different ways of measuring. Now generally whenever you have very long distance, we use parallax method. For very short distance, you can use light to calculate the distance. Okay, now when you say distance, look at the table. Here we have size of the proton. Proton is one of the smallest particles in the universe, correct? Because it's inside the nucleus. Obviously it's very small. From that to the biggest of the things, which is the size of the universe. Okay, size of the universe. Till here we have calculated so far. And guys, I'll be very honest here, the size of the universe changes because universe is expanding. each and every second the size of the universe is going to increase. So this is more of an approximated value. It's not an accurate value, it's more of an approximated value, but still it's a good approximation. Now whatever you're seeing, you can have from the most minute, that is nuclear level size, to the astronomical size. So length is one of the fundamental units, and the SI unit what we use for length is meter. Okay, now if you look at it, everything is in terms of meter, correct? Nothing is in terms of kilometer. Even though locally we use kilometer, meter is the SI unit. Alright, now this is the first fundamental unit. Now you're going to learn about the second fundamental unit.